In this video, let's understand what are tokens. So what we will cover in this video is that what is tokenization, why do we even need tokens, and how tokenization fits into the entire vector database pipeline. So these are the key concepts that we will cover in this video. So let's get started. So earlier in this vector database pipeline, we understood that the embedding model is responsible for generating, vector embeddings. So what we do is we ingest this raw data and the embedding model generates the vector embeddings. But the thing is, these embedding models, they don't understand this raw data at all because this is in text format, right? Or let's say it's audio format or video format, but these embedding models, they don't understand this raw data. So what happens internally within this embedding models is that this raw data is first converted into something called tokens, right? And these tokens are nothing but just some numerical representation of this raw data. And then internally, these tokens are converted into vector embeddings, right? And that's something that is done within this embedding model. So you don't have to do that, right? It's done internally, but you should understand what are tokens, because the tokens are actually the modern currency, right? It's the currency based on which you are actually charged, right? All the embedding models, they charge you based on the number of tokens, right? Not based on the size of the data you're ingesting, but based on these tokens. And that is why having a solid understanding of these tokens is important, right? So with that motivation, let's try to understand what are tokens. So tokenization is the process, right, of breaking down the raw data, right, into something called tokens, right? That's what is actually tokenization. It is the process of breaking down the raw data into tokens, right? So what happens is that, let's say you have this, your raw data, it could be text, audio, video, anything, right? You have this raw data, okay? This is sent as the input, right, to this tokenizer, and what you actually get, right, what you get out of it is tokens, right? And how the tokens actually look, these are just array of numbers actually, right? So what you get is just some tokens, right? Okay, so this is what is tokenization, right? So you have this raw data, that's the input to the tokenizer, and the output is some tokens, some numerical representation of the raw data, right? That's what is tokenization. Okay, so the first type is character tokenization, right? Then you could also tokenize based on the words, right? So that's known as the word tokenization, right? And then there is a third type that's known as the Subword tokenization, right? So these are the three types of tokenization that you will come across, right? So what is character tokenization? Let's try to understand these three types based on some example, right? So let's say that I have a text, I love vector database, right? Let's say we have this as the string, right? So in the case of character tokenization, what happens is every character, right? Every character is actually converted into some tokens, right? So how many characters you have here is some 13 unique characters. If you just try to check that, right, there will be 13 unique characters, right? So this will, using the character tokenizer, you would actually get 13 tokens, right? So using this character tokenizer, right, you would get around 13 tokens, right? So the problem with character-based tokenization is that the number of tokens would be huge, right? And that's not an optimal solution, because if you have, just imagine for this small sentence, right, you would have 13 tokens, right? Because if you then consider, like a huge sentence, right, and all the combination, all the different types of characters, the number of tokens would be huge. So the thing is that the character tokenizer, the main drawback is that the number of tokens increases, right? That's the main problem, right, of the character tokenizer, right? Now, if you consider the word-based tokenizer, how many tokens would you have for, if you consider, let's say, the word-based tokenizer now, right? How many tokens you would get out of it, right? There would be like 5 tokens, right? Five tokens. There are like 4 words, 4 distinct words, and then you have spaces as well, right? So you would get here 5 tokens, right? But then even the word tokenizer is not optimal, because if you see the English vocabulary, right, you would actually get, if there are like so many words in the English vocabulary, now you would have those many tokens, that's fine. But then there are certain words, like if you even consider the word tokenization, right, you would see that this word is made up of 2 subwords, actually, token and ization, right? And in English, there are many words that actually end with this, right? So token is already a word, we know that. And then there are many words that ends with ization, right? So if you consider now subword tokenizer, right? Yeah. If you consider subword tokenizer, it breaks down optimally words into smaller words, so as to reduce the number of tokens, right? So we could have used word tokenizer, but then the problem with word tokenizer was that every word would be treated as a unique word. So even token could be a unique word, and tokenization could be a unique word, right? Whereas in English, we know that the words can be broken down into smaller subwords, and that is where all the modern tokenizer that you have for ChatGPT or any large language models, we use the concept of subword tokenization, and I will explain this now with few examples to clarify this, right? So I hope you understand what are these 3 types of tokenization. First, we have character tokenization, which is based on characters. Then we have word tokenization, based on the number of words, right? And then you have the subword tokenization that breaks down words optimally, right? Now, this is something that's not done just randomly, right? It is actually done with a lot of, training to find the optimal, what is the optimal way to reduce the number of tokens, right? And as I saw those examples, this concept would be crystal clear. Okay, so now let's head on to this OpenAI platform tokenizer, and let's start with this example that they have here, right? So if you see this example, right, so you can see that this sentence, this paragraph, right, that you have here, that is converted into 53 tokens. And it says here, like, many words map into 1 token, but then some don't, right? Like, for example, if you see here, indivisible, right, that is actually broken down into 2 tokens, right? But then if you see these initial words, many, then words map to 1 token, these are all mapping to 1 token, right? Now, then it says that the Unicode characters, like emojis, may be split into many tokens, right, containing the underlying byte. For example, this emoji, right, that you have here, that gets converted into 4 tokens. And then it says that the sequence of characters commonly found next to each other may be grouped together. Like for example, 1, 2, 3 becomes one token, 4, 5, 6 becomes one token, and 7, 8, 9 becomes another token, right? So, and if you want to see those token IDs, you can see, those token IDs as well. So the concept is very important here, that many words, they are mapped into one token, but some words, they're mapped into multiple tokens. Then the Unicode characters, they gets mapped based on the bytes. And then we saw that sometime many common sequence of characters can be grouped together into one token, right? And this is all done based on the optimization that can be done to minimize the number of tokens. So you can see that if it was a character-based tokenizer, right, 252 characters, right, that would be 252 tokens, right? Whereas you have here just 53 characters. Okay, now let me try to explain this with few more examples, right? So if you see now these words, right? For example, organization gets one token, optimization, it gets one token. But then there are few words like standardization, globalization, right? They get split into two tokens, right? For example, global is one token, ization, and there are many words that ends with ization, and that's where you can see that all these words, we're able to use the same token of ization, and that is the concept of subword tokenizer, where the words are broken down to optimize the number of tokens. And if you want to see those token IDs, you can just switch to this token IDs tab, right? Okay, so that's the main concept that you need to understand about tokenization, right? And subword tokenizer is what all the modern LLMs use to optimize the number of tokens. So that's the key takeaway from this video. Hope you enjoyed this video. See you in the next one.